All right, in this video, we are looking at linear functions. By the end of this video, we want to be able to determine equations of linear functions. That's the primary objective. And then we'll look at distinguishing between parallel and perpendicular lines. And finally, we'll do one question on modeling a set of data to a linear function. To begin with, just an idea, and this is generally over lots of functions that'll be in this course, is that we often get mired in playing with x's and manipulating x's and solving for x and that kind of stuff. But don't lose sight of the fact that all math really is looking at this kind of process here. We look at national phenomenon or natural phenomenon and identify maybe a pattern. And we identify, well, maybe this is a pattern. So we collect a bunch of data and then we graph the data, and then we try and take a look at the data and see if it models or it compares to some established models. Like this one here would be a linear function, quadratic, cubic. This is logarithmic, exponential, sinusoidal. So we try and compare that data to those, and then if we can find an established model that it compares to, then we can say that that data is like a quadratic function. And if it behaves like a quadratic function, then that allows me to predict what numbers might be at certain times. So given a certain time, how high up will a ball be, for example? Or given a length of time, we can see what the blood pressure might be in a vessel, that kind of thing. So if I can model some data to some kind of a function, then that gives me power that I can predict what that situation might be in a given amount of time. So linear functions are very similar. That a linear function looks like this one. And what we'll do throughout the course is we'll look at all these different functions and we'll look at characteristics of them. And we'll try and match those characteristics to a function and match that to a graph. So linear functions, when we look at them, we might have a number of different information that they might give you. And what we're trying to do is to try and figure out what an equation for that function will be given whatever the information they give us. Any kind of linear function, like this one, can be characterized by two things. So the first is called the slope. I'm not sure why they use the letter m to represent that, but m is the thing that we represent for a slope, and that's just how steep that line is. So it's not a curve, but is it a real steep line like that? So does it have a high slope, or is it down here like this? So it doesn't have much slope. Or maybe it's just flat, so the slope would be 0. Or maybe it's perfectly vertical, in which case the slope of that line would be undefined, because there's no run to it, the slope would be undefined. Anyway, if we are trying to figure out what the equation of a line is, all I have to do is figure out what its slope is and figure out b, and b represents the y-intercept. So it's the y-intercept and m is the slope. So if I take a look at this line here in red, and I look to see where it crosses the y-axis. This is the y-axis here. It crosses that y-axis at that point right there. And that point is at -2. That point, typically, we write it as 0 and -2. So -2 would be my y-intercept. So if I was writing the equation for this line, for the b, for the y-intercept, I could write a -2 in there. And then I'd have to figure out what the slope is. Well, to figure out the slope, we can do that a lot of different ways. If I have the line already there, I can figure out the slope by figuring out how far something rises over how far something runs. And that's sort of the equation for a slope, is the rise over run. I guess I could write that, rise over run. We'll see another formula in a slide or two. But it's basically how much does it go up or down over how much does it go left or right. In this case here, I'm going up 2 units, so my slope is 2, or my rise is 2, and then I go over 1, 2, 3. So to get from this point to this point, I go up 2, and I run 3 to the right. So my slope would be 2/3. So the equation of that line would be y is equal to 2/3 x minus 2. And that would be the equation of that particular line there. So what I'm going to do in the next couple of slides is I'll show you different ways of arriving at that equation. Sometimes we won't know the slope, so we'll have to figure it out. Sometimes we won't know the y-intercept, we'll have to figure that out. Okay, so here's the equation. So they say the slope is -3/4, and they say the y-intercept is this. Oh, well, if they give you those two pieces of information, in my equation here, they're giving me m is -3/4. Okay, and then x is just there. And then they say the y-intercept is -2, so I put a -2 there. So if they said the slope is this and the y-intercept is this, there's my equation. Done. That's a nice, easy one. Let's try one. Here's one where they give me a slope. Oh, easy again. Y equals, slope is -2x. Oh, but they don't say what the y-intercept is. They give me another point that's on that graph, but it's not the y-intercept. So to figure out this question, I'm going to have to figure out what the y-intercept is. Couple of different ways to do that. The way I like to do it is I like to write my general equation, and then they give me a point, which is an x and a y value, and they give me the slope, which of course is the m value. So they give me a y, an m, and an x. So if I know all those, I should be able to figure out what b is. Okay, so let me erase this piece. So I'll erase this piece, and let's just plug all those numbers in. So y, a y value is 4, is equal to m, the slope is -2, and x is a -3, plus b. Do I have all that right? I think that's right. Okay, so 4 is equal to -2 times -3 is a +6 plus b. And then to solve for b, I'll subtract 6 on both sides. So I'll have -2 is equal to b. So my y-intercept is -2. So now that I know what my slope is and my y-intercept, I can write my equation. So my equation should look like this. I knew the slope from right there at the start, and I just figured out the y-intercept to be -2. It's interesting, the slope's been -2 every time. Hopefully it's not the same on the next question. Okay, so if I'm given the slope and a point, I can use this formula here to figure out what the y-intercept is, and then plug it in the equation. Another tool that they use in the book is they do show this equation here. No, that's an m, x minus x1. So they show that, and I think they call it the point slope formula. And you can use that as well. And what you do in this case is this point up here is an x1 and a y1. So this thing here you plug in for x1, and this here you plug in for y2 or y1, and then your slope you plug in right there, and then you solve or you simplify the equation and make it look like this. So you don't directly find what the y-intercept is. It sort of comes out as you're doing that step. You can try doing questions both ways. Just for me in my head, it's like I need to find out two things. I need the slope and I need the y-intercept. So if they give me the slope, good. Now I'm going to go after the y-intercept. This makes sense to me to figure out what the y-intercept is. Once I have it, then I can plug it into my general equation. Just try of doing it. So here's one where they give us 2 points and they want to know what the equation of the line is. Well, I'm just going to plot those. -2 and 1 would be right there, and 1 and 4 would be right there. So there's my 2 points, and what I want to know is what the equation is of the line that passes through both those points. Okay, so in the end, I'm going to want to know y equals mx plus b. I got to figure out m, got to figure out b. Okay, so first, to figure out the slope, what I could do is just from this point here to this point here, figure out how much I rise over how much I run. I could do that. Well, whoops, what happened there? Okay, so I could do that just by going 1, 2, 3 up, and then 1, 2, 3 over to the right. So my slope would be 3 over 3 or just 1. So I could do that, or I could use, the book shows you how to use this formula here. So y2 minus y1 over x2 minus x1. So basically the difference in y values over the differences in x values. Let's just use the formula and see if we can actually get the thing that we got from 3 over 3. Let's call this x1 and this y1. This will be x2 and this will be y2. Okay, so y2 is a 4 minus y1 is a 1 over x2 is a 1 minus x1 is a negative 2. So 4 take away 1 is 3. 1 minus a negative 2, careful with those negatives, is 1 plus 2, or 3, came out to the same thing. So the slope comes out to 1. Now this question is exactly the same as the question that we just did, because I know what the slope is and I know a point. And I can use either one of those points up there, it doesn't matter. I'll use the second one because there's no negative signs in it, but it doesn't matter which one you use. So what I'll do is I'll take this as my general equation. I've now figured out my slope, so my slope is a 1. And then I'll use this point, the x and the y values from that point, to plug in. So the x value is a 1 and the y value is a 4. Okay, plus b. 1 times 1 is 1, 4, and then I'll subtract 1 on both sides. So 3 is equal to b. So my y-intercept is 3. Whoops. Everything not moving up there. Okay, so then to write the equation of my line then, it's y equals mx plus b. I figured out the slope is 1, so it'd be 1x, and the y-intercept is 3, so plus 3. And of course, the 1 in front, I don't really need to write that. So I would say the equation of that line would be y equals x plus 3. Okay, so that's basically how you can determine the equation of a line given any of those things, whether there's 2 points or 1 point in the slope or a point in the y-intercept, whatever information. Now, when we're comparing two lines, we can determine whether they are parallel, perpendicular, or neither. Here I've got listed examples of two lines. There's two lines there, here's another two, and here's another two. And if I want to compare them in terms of whether they're parallel, perpendicular, or not parallel or perpendicular, I can do that based on their slope. So I'm always going to take a look at their slope. So in this first one, or let's do the middle one. I notice that the slope of these ones are both the same. If the slopes are both the same, so the slope of the first line is equal to the slope of the second line, then those lines are known as parallel lines. They'll never cross. They'll always stay the same distance away from each other. Now, if the slopes are like this one here, and these slopes aren't the same, but when you look at them, there's something funny. They're like they both have a 4 in it. So if the slope of the first line, if you take that one and you multiply it by the slope of the second line, if when you do that you come out to -1, then those slopes are known as perpendicular. You might have heard of these as being called a negative reciprocal of each other. So here's 4, and if you change its sign from positive to a negative, and you flip it over, so instead of 4 over 1, it changes to 1/4, then those lines are perpendicular. If you multiply the slopes, the first slope is 4 times the second slope is -1/4. When you multiply it, it's going to be negative. The 4's cancel, 1 times 1 would be a 1. So it does come out to that. But if you think in your head negative reciprocal of each other, then those lines are perpendicular. Now, if neither one of those rules apply, if the slopes aren't the same, or if they're not negative reciprocals of each other, then what you have is two lines that aren't perpendicular nor parallel, and basically those two lines would just cross. So they won't cross. Perpendicular would be they'd cross at 90-degree angle, and parallel would be lines that go the same direction and they would never cross. Here's an one where you try and figure that out. But here I gave you the equations in a funny format. So each of these, I can't really tell what the slope is without changing its form. So if I take this first equation and let me write it down here. 2x minus 3y equals 5. And what I'm wanting to do is to get it written in this form, because if it's written in this form, then I can figure out what the slope is. So I'll subtract 2x from each side, and then I'll divide everything by a negative 3. So this would be y is equal to a positive 2/3 x plus something. And here I'm just determining whether they're parallel or perpendicular. So this thing here doesn't really make any difference. Okay, let's do the same thing for the other one. 3x plus 2y is equal to 7. So let's subtract 3x from both sides. So the 3x becomes negative on the other side. And then I'll divide everything by 2. So this would be y equals negative 3 halves x plus something. Now, if I take a look at the slopes, this slope here compared to this slope, they're not the same, therefore they're not parallel. Are they negative reciprocals of each other? So does the sign change? Yes. And do they flip over? They do. So these two lines here would be perpendicular lines. Okay, the last thing I wanted to do in this video is just to show you an example of how we model data. Here is an example of some data I just grabbed from the internet somewhere. This is apparently this is a bike weight, and given the weight, how high you can jump with that particular bike. And I don't know if it's bunny hopping or what kind of jump it is. Anyway, so if your bike weighs this much, then an average height of jumping would be 10.35. If your weight is 24, then the average height would be of the jump would be a little bit less. And that makes sense. A heavier bike, it's going to be harder to jump in. I've taken and I've plotted the data over here. And notice it is not perfectly straight, but when you take a look at it, generally there's a straightness to it. So if I were to draw a line of best fit, it might be something like that. Now, what you can do if you want to say, hey, well, that looks like it could be a linear function, then what you can do is if you draw a straight line, really what you would do is draw a straight line and then you'd find a point that's on that line. But typically what we do is we just take a representative point here. And so I'll take the first point, and you don't have to take the first and the last point. Those are typically the ones that I do. But as long as the points aren't, way off of the line, typically this will work. So this I would call x1 and this y1. This I'd call x2 and y2. And then I do exactly the same thing as I did on that slide before, or the one before that one, where you have 2 points. So I have the point 19 and 10.35, that's 1 point. And I have the point 24 and 9.6, that's the second point. And so this value is an x1, y1, x2, y2. And then I'd use my formula to figure out what the slope was. And then once I know what the slope was, then I'd plug it into my general equation. So I'd take the slope, whatever I figure out, I'd plug it in here. And then I'd take one of the points, maybe take this point and plug the x value in there and plug the y value in there and solve for b. And then I'd rewrite the equation with whatever my slope was and whatever my y-intercept was. And that would be the equation of the line that models that data there. All right, hopefully that helps. Try some questions from the textbook and let me know if you have any questions.